So section 10.4, I'm skipping 10.3 for now. And actually, 10.3 I'm going to cover tomorrow, and might put a question on the final exam for extra credit from this section, 10.3. So I'm just going to make sure to finish the mandatory sections today. Section 10.4, it's called Analysis of Variance. And it has a name here, Anova. Analysis of variance. Okay, let me tell you what this test is about. That's a very easy test, guys, to perform. Probably one of the easiest tests that you ever learned. You learned how to compare one mean, test like whether a mean greater than some value, greater than 15, less than 15 in chapter 7. And in chapter 8, guys, you learned how to compare two means from two different populations, mu1 and mu2, and you tested like mu1 equals mu2, mu1 not equal to mu2, mu1 greater than mu2, etc. What about if you want to compare more than two means, 3 or more means? None of the tests, guys, that you learned will be able, to address, just our questions, because what we learned in chapter 8 is only good for 2 samples. But what about if you have 3 or 4 samples from 4 different populations? For example, there is an exercise in the book that says the stay, at the hospitals, just changes from one state to another. It's not the same for a certain surgery. Let's say, for a heart surgery, there's someone who's making the claim that if you are in the Midwest, you would stay a number of days, at the hospital. If you are in the West, you would stay a different number of days. And if you are in the East, just the number of days you stay at the hospital is different. So if you want to study a claim, whether the stay is the same, just in all regions or not, you need, just a technique different from what we use to compare two means, because here we have more than two means. We have 3 means, 4 means, etc. So then we need a test which is called analysis of variance. And the analysis of variance is used to compare more than 3 means. Now, the good thing, just about the analysis of variance, to test this, HO and HA will not change from one problem to another. Let's say you are comparing, just more than 3 means. So your HO will be always, guys, mu1 equals mu2 equals mu3 equals mu4. If you have more, equals, etc. That will be the null hypothesis. The alternative hypothesis will be this language always. At least one of the means is different from the others. And let me show you some examples, guys, of what kind of questions we'll be testing right here. So here is a question in 10.4. We're not going to do any of the work, just by hand. It's all going to be on the calculator. Here's one question. The table shows salaries in thousands of dollars for a sample of individual from the federal, state, and local. You see, you have 3 samples, 1, 2, 3. You cannot use chapter 8 anymore. And local levels. Can you conclude that at least one mean is different from the others? You see, guys, I just stated the null and the alternative. At least one mean is different from the others. And the null will be always mu1. In our case here for this exercise will be mu1 equals mu2 equals mu3, because I only see 3 samples there, 1, 2, 3. Let's look at another one. Age of professional athletes. The table shows the ages for a sample of professional athletes from several sports. At alpha equal 5%, can you conclude that at least one mean age is different from the others? So here you have mu1 equals mu2 equals mu3 equals mu4. At least one mean is different from the others, and you have the data. Here's another one talking about hospitals. In a recent study, a health insurance company investigated the number of days a patient spent at the hospital. In part of the study, the company selected a sample of patients from 4 regions in the United States and recorded the number of days each patient spent at the hospital. The table shows the results of the study. At alpha equals 1%, can the company reject the claim that the mean number of days spent at the hospital is the same for all 4 regions? So the null here would be mu1 equals mu2 equals mu3 equals mu4. And the alternative hypothesis, guys, will be at least one mean is different from the others. What we're going to have to do, the only work that you have to do here is to enter this data in L1, L2, L3, and L4, and then I'll show you how to run the test here. So this is just to give you an idea of what the analysis of variance test is about. So I'm going to go to this section right now, 10.4. Okay. So for analysis of variance, this is how you state HO, and this is how you state HA. And assumptions of the test. In order to run the test, we have to make some assumptions, and the assumptions are the following, guys. Let me just state those assumptions right here. The first assumption is the samples are independent of each other's. That's assumption number 1. Assumption number 2, the samples are random. And selected from normal populations. So that the original population has to be bell-shaped. And assumption number 3, guys, for the test. But when I ask you to run the test, you just run it. But you need to know about, just the assumption. Assumption number 3, populations have the same, each population has the same variance. All right. What we're going to be using to perform this test, it's called an Anova test. We will require a distribution called an F distribution. And let me show you how that F distribution look like. So that's the last distribution you'll learn about, guys, I promise. It is a positively skewed distribution like this. It starts at 0, so it's always positive. Total area under the curve is equal to 1. It has 2 degrees of freedom. One is called degrees of freedom of numerator n, and one is called degrees of freedom of denominator. And as the degrees of freedom of numerator and denominator increase, the shape of the distribution will become just like a bell-shaped curve. So this is the F distribution. And we're going to show you now how to perform the test. It's very, very easy test, guys. You will see. A medical researcher wishes to try 3 different techniques to lower cholesterol levels of patients with high cholesterol level. The subjects are randomly selected and assigned to one of the 3 groups. Group 1 is given medication, Group 2 is given exercise program, and Group 3 is assigned a diet program. At the end of 6 weeks, each subject cholesterol level is recorded. Test the hypothesis that there is no difference among the means. So guys, you start with HO, mu1 equals mu2 equals mu3. HA, at least one mean is different from the other, as I said. Can a student tell me where is the claim now? Test the hypothesis that there is no difference amongst the means.
HO.
Yep, no difference means equal. You are correct. Okay, go put this in L1, L2, L3. Nothing we can do if we don't input the data, guys. There's nothing you can do. Let's do that. So I got 11, 12, 13, 15, 9, 8. Oops, I put him. It doesn't matter, actually. L1, 8, 3, 5, 2, 4, 0. L3, 4, 12. The sample size don't have to be the same. They happen to be the same, but they don't have to be the same. Whatever they collect, that's fine. All right. And now, guys, you go to stat. It's scroll up, guys. It's the last test on the screen. It's called Anova. Any ideas? What do I have? What the calculator is waiting for, guys?
You to input L1, L2, and L3.
Yep, you got it. That is exactly correct. Stat, tests, Anova. And when you input L1, L2, L3, separate them with a comma, guys. So just let's do that. Look, second, and then number 1. Oops, you don't see 1. Then I put a comma, then the second, and number 2. Then I put a comma, then if you have 5 sets, guys, you do L1, L2, L3, L4, L5. So that's it. And close it. There you go. The test statistic is called F because we're using the F distribution here. So F is 11.09. P-value, guys, you can see it right here. 0.0011, which is less than alpha, of course. 0.05. Reject HO. And my conclusion, guys, there is enough evidence to reject the claim that there is no difference amongst the means. At the 0.05 level of significance, to reject the claim. There is the claim. I just copy it from here that there is no difference amongst the mean. So probably there is a difference, guys. It does matter which diet or which program. There's no difference. Okay, so that's what we call Anova test. What happened to my screen? Stop share. Okay, just